Alright, so here's the key for your kind of practice assessment on target 7b. So we're doing some law of sines, law of cosines stuff. The first problem I gave you, to determine the measure of all unknown sides and angles of the triangle, diagrammed at the right. So just a quick diagram of this guy. We're looking at 110 degrees, 28 centimeters, and 45 degrees. And it's labeled A, T, and C. So we gotta find all the missing information. So you kind of gotta look at it and you get a feel for, well, what kind of information do I have? Am I gonna be doing law of sines, law of cosines? And as I look through this, I have, I have the 110, and I'm missing its side. That's little t. And I have the 45, and I have its side, which is 28. So I've got enough information here to do law of sines to find t. So I'm going to use law of sines. And we should also mention, because you have these two angles, you're going to get the third one for free. Right? Add them up, subtract from 180. So 110 and 45 is 155, and 155 is 25 short of 180. So now we need to find this side here and this side here. So we'll get t first. So we'll go sine of 110. Sine of 110, 110 degrees over the unknown, which is t, equals sine 45 over 28. I want to isolate t. So first off, I'm gonna multiply both sides of the equation by t, and then also by 28. So that'll get rid of the fractions. So I'm sitting with 28 sine 110 equals sine 45 times t. If you want to isolate t, you can divide both sides by sine of 45. So you're just going to compute what's on the left, and you'll have t. If I were typing this into my calculator, I'd put a set of parentheses around the entire numerator. So let me type that in real quick. Check the mode on my calculator. It is degrees. So I'm looking at 28 sine 110 divided by sine 45, and that is approximately 37.21. 37.21. 37.21. Okay, so you're missing one more side. Now please don't try to do Pythagorean theorem. It's not a right triangle. So yes, you have two sides, but you can't do Pythagorean theorem because it's not a right triangle. So now you got to think, okay, well, let's see. I'm looking for this side. I know its angle. And I could pick another side, like the 28, and I know its angle. So I'm set up nicely again for the law of sines. So we'll get rid of this. We'll move this below. Maybe. No, we'll get rid of it. Okay. So get that work off to the side. Okay, so we're set up nicely again for law of sines. So it goes sine of 25 over the unknown. Okay, we can call that, that'll be A, equals sine of 45 over 28. Okay, multiply both sides by 28 and A. Some of you are thinking, wow, cross multiply, it's two fractions separated by an equal sign. Yes, that's really the only time it'd be appropriate to cross multiply, two fractions separated by an equals, but I still don't like to do it. So, same effect. I'm going to get rid of the fractions, so multiply both sides by 28A. 28a. On the left side the a's go, and on the right side the 28's go. So you have 28 sine 25 equals sine 45 times a. So to isolate a, you just divide both sides by sine of 45. So a equals 28 sine 25 divided by sine of 45. And a is approximately, so I'm going to type that in my calculator, 28 sine 25 divided by sine of 45 is 16.73. So we can fill that in. So, and I would know, right, that triangle is solved. Now here's the last check, okay? Make sure you have, maybe it's not you're not going to be able to, say, specifically check all of your answers, but you want to look, is the largest side across from the largest angle? Okay, well that's the largest angle. Is 37 the largest side? Yes. The next largest side should be across from the 48, or 45. Across from the 45 is the 28, which is bigger than 16.73. So that matches. So at a minimum, as far as checking your answer, make sure that the largest side is across from the largest angle. The smallest side is across from the smallest angle. So in that problem, think about what we had to use. We actually just had to use law of sines. Okay? We solved that triangle with just law of sines. Sometimes you'll have to use both law of sines and cosines, but not there. So, next one. Determine the measure of all unknown sides and angles. So they give us the diagram. Give us that guy, that guy, that guy. They called it Z, E, and N. I'm not going to use Z because I'll confuse it with the number 2. So I'm going to call it H. Actually, you know what? You have Z on your paper, so we'll do Z. Z, E, and N. So you got 150, you got 135, and you got 48. You don't have enough information here to use law of sines, so we're going to have to start with law of cosines. Okay, so, the reason I say, hey, you're not going to have enough information for law of sines is, let's say you tried to do law of sines, okay, and let's call this is n over here. So you'd be going, oh, well, it's sine of 48 over n equals sine of, wait a second, sine of e over 150. Well, you've set this proportion up, and you have two variables that you don't know. So at that point, you'd go, oh, I can't use that. One equation, two variables, I'm not going to be able to solve. So we can do this, though. We can do law of cosines. So I'm going to go law of cosines to get n. So I'm going to go n squared equals, I'm going to have the cosine of angle n, which is 48. So I got a 150 squared plus a 135 squared minus 2 times 150 times 135 times the cosine of 48. So on the left, you really have three things, okay? You got the 150 squared plus the 135 squared minus this guy here. Okay. Addition and subtraction separates terms. Okay, that addition and subtraction. So you're going to need to go ahead and compute each of these terms. You could do them separately, or you could just type this whole thing into your calculator, and then you can combine them all. So just in my calculator, I'm going to go, I would actually just type in 150 squared plus 135 squared minus 2 times 150 times 135 times the cosine of 48. When I do that, I get 13625.2. So solve for n, you take the square root of both sides. So if I raise that answer to the 0.5, which is taking the square root, I get 116.727. So that's n. Now you've actually got enough information to go back and use law of sines. So I'm going to try to get angle z, get this guy right in here with law of sines. So I can go sine of angle z over its side, which is 135, equals sine of 48 over 116.727. So ultimately you're trying to solve for z, right? Angle z. But before you isolate angle z, you're going to have isolated sine of z. So if you want to isolate sine z, you'd multiply both sides by 135. So with my calculator, I'm actually going to take this blue thing right... Oops. I'm going to take this blue thing right here, and I'm going to multiply it by this orange thing right here. That didn't turn out well. How about this yellow thing? So I got to compute this. So I do it in two steps. I'm going to go sine of 48 divided by 116.727. I'll get that answer. I'm going to multiply that answer by 135, and I get 0.859. So I've got sine of z isolated now. Sine of angle z equals 0.859. Now z is trapped inside the sine function. So to get it out, you have to apply inverse sine to both sides. Right? What you do to one side, you do to the other. So the left side is sine of z. The right side is 0.859. Applying the inverse of a function to the function, they're going to cancel out, and just z is going to drop out. So you'll have z is approximately, you grab your calculator, you're going to go inverse sine of 0.859. 59.2 roughly. 2 degrees. So 59.2 degrees. These two added up, then subtract from 180. So that guy plus 48. So 59.2 plus 48. 180, subtract that. 72.8. So our angles are in blue here. Those are your three angles. Your sides are going to be in green. 1, 2, 3. Okay, quick check. Is your largest side across from your largest angle? Yes. My largest side is across from the largest angle. My smallest side is my smallest side across from my smallest angle. My smallest is 116. It is across from the 48. Okay, this was the last one. This is the whole local youth sports stadium. They give you the configuration. You just want to find the area of it. So you're going to have to break this up. Now, you're kind of thinking, okay, well, how am I going to draw these sides? And, I wouldn't break up an angle that you know. Because when let's say you length these two sides here. Well, then you don't know either of these angles, this one in here or this one here. So, when I think about cutting it up, I don't want to compromise one of the angles that I know. So, I'm going to break it up. I'm going to go here to here, and then here to here. So I'm really going to work with 3 triangles. Purple, green, and we'll go red. So those are the 3 triangles I'm going to work with. So those kind of clutter the diagram. So let's see. To find the area of a triangle, I go 1/2 AB and then sine of the of C, which is the angle in between A and B. So I can actually get this triangle right there because I have the angle and the two sides that surround it. I could also get this triangle right here, but I couldn't get the middle one yet. I don't have enough information. So you kind of got to go on a little, explore a little here. So think, okay, let's see. I need to know an angle. I don't know. I need to know an angle with that purple triangle in the middle. So I'm confident I could get this side x. Okay, I could get x using law of cosines on the 4, 10, 75, 99 triangle, and I could also get y here using law of cosines on the other triangle. So I'd have the three. Oh, cool! That would be it. Then I'd have the three sides of that purple triangle. I could use law of cosines and get any one of the angles, and then use my area formula right up there. So that's what I'm going to do. I'm going to get x, I'm going to get y. So let's see. So x squared is 410 squared plus 75 squared minus 2, 410, 75 cosine of 99. Okay, so what's cool is you can actually just type that whole mess into your calculator and then take the square root of it and you'll get x. So when you do that, I'm just going to go, okay, calculator, do the square root of 410 squared plus 75 squared minus 2 times 410 times 75 times the cosine of 99. 428.19. Okay, 428.19. Okay, now I'll get y. See, y squared equals 70 squared plus 400 squared minus 270, 400 cosine of 105. Once again, I'm just going to take the square root of that entire right side. So the square root of 70 raised to the second plus 400 raised to the second minus 2 times 70 times 400 times the cosine of 105. 423.55. So that's y. 423.55. Okay, so we mentioned previously we could get the area of this triangle, we could get the area of this triangle. The middle one, we still need an angle if we're going to use our formula. So let's go with, we can pick any one of the angles. Let's say we chose this one right here. Let's try to find that guy. We'll call that guy theta. Okay. So we would go. So what's the side opposite theta? That's your 423.55. So you go 423.55 squared equals 428.19 squared plus 20 squared. We're running out of room here. My battery's getting low. Minus 2 times 20 times 428.19 times the cosine of theta, which is that angle right there. I'll pause it and go plug this in. So now you just have to isolate theta, right? But before you isolate theta, you're going to have cosine theta isolated. So I'm going to bring that guy over and that guy over with subtraction. Okay. I can do that. So I'm going to minus 428.19 squared. And I'm going to minus 20 squared. So let me compute that. 423.55 squared minus 428.19 squared minus 20 squared. Okay. That's negative 4351.85. And that equals negative 22428.19 cosine theta. So we're trying to isolate cosine theta. So the stuff connected to cosine theta is all connected to it through multiplication. So we're actually going to divide both sides by that entire blue amount. So divided by blue. So negative 22428.19. So if we divide both sides by that, these will go away. So divided by, let's put this guy in parentheses, negative 2 times 20 times 428.19. Okay. So this guy right here, I have computed that with my calculator, and my calculator says that that is 0.254. And that's equal to the cosine of theta. So if you cosine inverse both sides, the right side turns into theta, and the left side, well, cosine inverse of 0.254, 72.28, no, 75.28 degrees. You might have a little bit different answer because I'm using the answers from my calculator. I'm actually not really rounding in between. So, okay, so that angle that we found right there, this guy right here goes right here. And the whole idea was getting that angle, we can then get the area. So let's put that angle in there. 75.28. Okay, so now we got to use our area formula. So you have three separate triangles. Okay. So let's go this orange triangle right here. Oh. That orange triangle. Okay. The area of that orange triangle we can get. Let's see. It's 1/2 75 410, and then the angle between the 75 and the 410 is the 99. So sine of 99. Okay, that'll be the orange, and we're going to add that to 1/2. So let's get another triangle. Let's say it was this blue one. So for the blue one, I'm going to use the 428.19, the 20, and the angle between them. So 428.19, the 20, and then the sine of the angle between them, which is 75.28. And then plus, because I'm adding all three triangles together, the third one we'll do in yellow. So I'm going to use the 105 degree angle, which means I'm going to use the 400 and the 70. So 1/2 470 sine of 105. So I got to add all three of those together, and I'll get you the final answer here in just a second. All right, so I got a final answer here for you: 32,850 square units. So nicely done. That's an involved problem, but I tell you what, if you can do that, you understand target 7B, which is understanding the application of trigonometric functions. Specifically just law of sines, law of cosines, and their application. So nicely done. Thanks a lot. I hope you do well with tomorrow's assessment, if you're taking an assessment tomorrow.